I'm Sam Serio, and we are here to tell you about forces. Before we do that, I have a few simple terms that I need to define. Mass is the amount of stuff in an object. Mass does not change depending on the force acting on it. The next term is force. Force is something that changes an object's motion. One way to calculate force is by multiplying the object's mass by its acceleration. The next term is acceleration. This is how much a velocity, or a speed in a certain direction, changes over a given amount of time. The last term is equilibrium. Forces are special because they are vectors, which is a magnitude in a given direction. If two forces have the same magnitude and they're going in opposite directions, they cancel each other out. This is equilibrium. There are two different types of equilibrium. There is a static equilibrium, and there's also dynamic or kinetic equilibrium. Static equilibrium occurs when an object is not moving. The object is at rest because there is no net force acting on it. For kinetic equilibrium, the object is at constant velocity. It is not accelerating because, like in static equilibrium, there is no net force acting to cause an increase in acceleration.
Hi, I'm Will Chestnut, and I'm here to talk about Newton's 3 laws. The first law says that an object that already is in motion will continue to be in motion, or an object at rest will not move unless acted on by an outside force. This force will disrupt the kinetic or the static equilibrium. This equilibrium is a word that we defined before by Sam Serio in the previous part of this video. I would like to demonstrate Newton's first law. As we see here, we have a water bottle that is not in motion on top of my hand. If I were to hit the water bottle, I would cause an outside force on this object, propelling it into motion, which would disrupt its kinetic or static equilibrium. Newton's second law deals with objects that are not in equilibrium. This object allows us to calculate the acceleration of an object, or the change of velocity on an object. Newton's second law says that the net force, which is all the forces that aren't canceled out, divided by the mass, equals the acceleration of an object. Newton's third law says that with every action, there is an equal and opposite reaction. An example of this third law would be if I was to, per se, kick this wall or punch it. With both, there is an equal and opposite reaction that the wall gave to my hand.
Alright, so now we're going to move on to special forces. There are 4 types of them. They're weight, normal force, tension, and friction. And the first type, weight, is actually different from mass, and the reason being that mass is always constant no matter where it is, and weight changes depending on the gravity of the area that it's in. So on Earth that'd be about 9.8 meters per second squared downward. And so if this was 1 kilogram, which it's not, but if this was 1 kilogram, just multiply by 9.8, so this would be about 9.8 newtons, because the unit for weight is newtons. So the normal force is also called the support force because it opposes the weight. Whatever the weight that an object is, the support force is going to apply the same exact force in opposition. So this is, like I was saying earlier, this is 9.8 newtons. So you put it on that table. The table now has 9.8 newtons of support force because it's not breaking. So the support force will always oppose the gravitational force. Alright, so the third type of special force is tension. It is the force that acts on a rope, on a string, like this. The force is actually directed from the object with the end toward the top because So if I pull down here, the tension will increase. Alright, so the fourth type of force is friction. It's a force that opposes motion. So if this pen were to be going that way, which it is, the friction would oppose it because that's what friction does, it opposes motion. Yeah, motion's that way, friction would be the opposite of the direction it's going. There are two types of friction, static and kinetic. Static friction is when it's not moving because, say I'm trying to push this, but the frictional force is too great, so it just stays in place, that'd be static friction.
Okay, yeah.
And
notice.
Static friction is going to be greater than kinetic friction because the coefficient of static friction is greater than the coefficient of kinetic friction. The coefficient of friction is also greater on a rough surface than smooth because if you have a lot of, like if you have sandpaper, that means there's more friction, which is why people use sandpaper instead of regular paper to do stuff that sandpaper does. So